Good morning. I am Dr. Job Thomas from Cochin University, and I am going to talk on ultrasonic pulse velocity tests in concrete. Ultrasonic pulse velocity test is a non-destructive test of concrete, and it is conducted on the built concrete structure. The non-destructive testing is the process of testing of concrete without damaging the structure. And it is done for three aspects. One is quality assurance, and prior to purchase, anybody wish to do the quality assurance of the structure, then it should be done. And then dispute settlement, if a contractor claims for a higher quality of concrete, then it should be done. And then forensic investigation when a structure damages due to something, and if it is for material reasons or material strength reasons, it is being assessed based on the non-destructive testing. And for example, if you want to purchase a mall, a figure is shown here, where you can see that lot of beams, a lot of structural members like beams, columns, walls, etc. being constructed with concrete, and its quality need to be assessed based on this particular test. And what you get based on the non-destructive test is given in this slide. One is strength of the concrete, and another is uniformity in quality of concrete. So the very common non-destructive tests are, one is ultrasonic pulse velocity test that I am going to discuss today. Other one is rebound hammer test, and we will just see how this ultrasonic pulse velocity test is being conducted. See, in working principle, if you see a figure of ultrasonic pulse velocity meter is shown in this slide, and there you can see three components altogether. One is transmitter, another one is receiver, and third one is the time measuring device, that is a box. The red color one is the transmitter, and the green color one is the receiver. The transmitter and the receiver props are pressed against the concrete surface where the testing is to be done, and the physical distance between the props are measured, and then the time required to traverse the ultrasonic pulse from the transmitter to receiver is recorded. If the concrete is firm, or if there is any no damage in the concrete, then the pulse will traverse a straight line directly from the transmitter to the receiver. And if there is a damage in the concrete, shown in a blue color, it traverses around the damage, and as a result it takes more time to reach at the receiver point. So in this approach, we will calculate the apparent velocity as the velocity is equal to the length between the receiver and the transmitter divided by the time taken for the traverse. The apparent velocity will be high for direct traversing and non-flow concrete, and the apparent velocity will be low for damaged concrete or cracked concrete. In the test procedure, we have some steps to be followed. It is listed in this slide. Locate the dry location in the structure where the tests need to be conducted. Then clean the surface of the concrete to remove the grits and scales. Smoothen with a grinding wheel. Mark grid of size 300 by 300 mm on the surface of the structure. So in this figure, it is shown in a wall structure how it is being done. You can see that the entire structure is being divided into grids of size 300 by 300 mm on both faces where the testing is to be done. And measure the distance between the grid points where the transmitter and the receiver are to be placed. Then apply the grease or petroleum jelly on the grid points so that the probes will get a better contact on the surface. Press the transmitter and receiver on the predetermined grid points and switch on the ultrasonic machine so that the traverse length is being displayed on the machine. So you see the figure here. The transmitter and receiver is kept on the opposite face of the wall, and when you switch on the machine, you will see the display is is changing, and the time of traverse will be displayed on the machine, and based on this you compute the apparent velocity. And how to interpret the result? The first is quality grade of concrete. If the velocity is greater than 4.5 km per second, the concrete is said to be good quality. If it is between 4.5 to 2.5, the concrete is said to be medium quality, and if it is less than 2.5, it is said to be doubtful case, so more tests need to be conducted. And how the uniformity in quality is being assessed, that is given in this slide. The range or the difference between the maximum and minimum magnitude of apparent velocity is considered. If it is less than 0.5 km per second, then it is said to be of uniform quality, and if it is greater than 0.5 km per second, it is said to be under the doubtful condition. There also more tests need to be conducted. Thank you very much for your kind attention. Thank you.